A very good afternoon, student. Today, let me start the physics class. Hereafter, I am Johnson Samuel taking your physics class. So, today's topic is series connections of parallel resistors. Series connections of parallel resistors. So, already you have learned in the previous topics what is meant by series circuit, what is meant by parallel circuit. So this is the combination of parallel circuit with the series circuit pattern. So series connections of parallel resistors. So this is very important topic for your um, detailed question. If you consider the connections of a set of parallel resistors that are connected in series. So connection set of parallel resistors. This is a set of parallel resistors which is connected in the series circuit. You get a series parallel circuit. Let R1 and R2, this is here, R1 and R2 be connected in parallel to give an effective resistance of RP1. RP1 means parallel resistance, effective parallel resistance, RP1, this set. Then similarly, the second set is let R3 and R4 be the connected in parallel to give an effective resistance of RP2. Then both of these parallel segments are connected in series pattern. So both the segment connected in the series pattern, series circuit pattern. These two sets of parallel resistance which is connected to the battery in series circuit. So using equation 4.18, already the last class we have learned in the previous topic. So from this resistance in parallel circuit, equivalent resistance or effective resistance in parallel, what is the formula for the effective resistance in parallel? 1 by Rp is equal to 1 by R1 plus 1 by R2. Here 1 by Rp1, that means first set of parallel circuit. 1 by Rp1 is equal to 1 by R1 plus 1 by R2. Then second set of parallel circuit, effective resistance of parallel circuit is 1 by Rp2 is equal to 1 by R3 plus 1 by R4. So finally using this equation 4.12, the net effective resistance is given by total resistance. That means effective resistance in series. What is the formula for the resistance in series? R is equal to R1 plus R2. Here R total resistance R is equal to Rp1 plus Rp2. This is the effective resistance in series pattern. So here this is a circuit, two parallel set of resistance circuit connected in series manner. So that is why the formula is total resistance in series is equal to Rp1 plus Rp2. That means parallel resistance of effective resistance plus sum of the effective resistance in parallel in first pattern plus sum of effective resistance, parallel resistance in second pattern. Once again repeat, total resistance in series which is calculated by effective resistance in parallel 1 pattern plus effective resistance in parallel 2 pattern. So this is the important formula of series connections of parallel resistors. The next, parallel connection of series resistors. So last topic, series connection of parallel resistor. Here the next topic is parallel connection of series resistor. So here if you consider the connections of set of series resistors, here this is the set R1 and R2 is the one set of series circuit, then R3 and R4 will be the resistance in another one set of series circuit. Both the series resistance circuit which is connected in parallel pattern. What happened? Series circuit connected in parallel circuit, you get a parallel series circuit. So let R1 and R2 be the connected in series to give an effective resistance of RS1. RS1 means resistance in series first pattern. Similarly, let R3 and R4 be connected in series to give an effective resistance of RS2. RS2 means series effective resistance in series in second pattern. So then both of these serial segment are connected in parallel. This is parallel circuit. So what is the equation of series circuit? So resistance in series means R is equal to R1 plus R2. Here RS1 is equal to R1 plus R2. RS2 is equal to R3 plus R4. Finally, let me calculate the effective resistance in parallel. What is the formula of parallel resistance? Effective resistance in parallel. 1 by Rp is equal to 1 by R1 plus 1 by R2. Here 1 by R total resistance is equal to 1 by S1 plus 1 by S2. So this is very important formula for the parallel connections of series resistors. Parallel connections of series resistors. The next very important topic, 2 mark question. Please note it down, children. Listen carefully. Difference between series and parallel connections. Difference between series and parallel connections. So the difference between the series and parallel circuit may be summed as follows in table 4.3. This table is very important for your 2 mark question as well as the objective type question also. So difference between the series and parallel circuit criteria are, there are 3 important points. First point is equivalent resistance. Criteria is equivalent resistance for a series circuit more than the highest resistance. So equivalent resistance for the series pattern of circuit more than the highest resistance. For parallel pattern, parallel segment of circuit, less than the lowest resistance. Once again repeat, equivalent resistance for the series more than the highest resistance. For parallel, less than the lowest resistance. Then second point is, criteria is amount of current. Amount of current. Current is less as effective resistance is more. Current is less as effective resistance is more. If the resistance value is more means definitely the current will be in decreases. So current is less as effective resistance is more. For parallel segment, amount of current is more as effective resistance is less. So when the value of the resistance is decreases means current is increases. So vice versa, resistance is always inversely proportional to current, because when the current is increases, resistance is decreases. When the resistance value is increases, automatically the current value is decreases. So that is why for the series segment circuit, current is less as effective resistance is more. For parallel, current is more as effective resistance is less. Next, third important point. Third point criteria is switching on or off. For the series, if one appliance is disconnected, if one appliance is disconnected means all others also do not work. So if any one of the appliances disconnected, others also do not work for the series segment. For the parallel circuit, if one appliance is disconnected, others will work independently. Once again repeat, switch on and off condition for the series, if one appliance is disconnected, other also do not work. For the parallel condition, if one appliance is disconnected, others will work independently. Next important topic is heating effect of current. So this is also very important topic in the electricity lesson. Heating effect of current. This topic is very important for the objective type as well as the 2-mark question, then detailed question also. Have you ever touched the motor casing of a fan which has been used for a few hours continuously? What do you observe? The motor casing is warm. So, in practically day-to-day life, when we switch off the fan, then we will touch the fan, means definitely the fan which we feel some heat energy from the fan surface. So the same point is mentioned this sentence also. Have you ever touched the motor casing of a fan which has been used for a few hours continuously? What do you observe? The motor casing is warm. This is due to the heating effect of current. The same can be observed by touching a bulb which was used for a long duration. Generally, a source of electric energy can develop a potential difference across a resistor which is connected to that source. This potential difference constitutes a current through the resistor. For continuous drawing of current, the source has to continuously spend its energy. A part of energy from the source can be converted into useful work and the rest will be converted into heat energy. So this point is very important point, children. Please note it down. A part of energy only from a source can be converted into useful work and the rest will be converted into the heat energy. So this is a very important points. Please note it down. Thus, the passage of electric current through a wire result in the production of heat. Once again repeat. The passage of electric current through a wire result in the production of heat. This phenomenon is called heating effect of current. This heating effect is current is used in devices like electric heater, electric iron, etc. The next topic is Joules Law of Heating. Very important topic. Please listen carefully. Joules Law of Heating. Let I be the current flowing through a resistors of resistance capital R and V be the potential difference across the resistor. The charge flowing through the circuit for a time interval T is Q. Q is nothing but charge. T is nothing but time. The work done in moving the charge Q across the end of the resistor with a potential difference of V is V into Q. That means potential difference into Q. That means product of the potential difference and the charge. This energy spent by the source gets dissipated in the resistor as heat. Thus, the heat produced in the resistor is H is equal to W is equal to VQ. That means heat is the kinds of energy. Energy is nothing but work. So that is why H is equal to W is equal to V into Q. That means potential difference into charge. That is otherwise called product of the potential difference and charge. You know that the relation between the charge and current is. So what is the formula for the current? I is equal to Q by T. Rearrange the equation. We obtained Q is equal to I into T. That means current into time. So charge which is equal to current into time. Using this, you get H is equal to VIT. H is equal to VIT. VIT means potential difference into current into time. IT is nothing but Q can be replaced as the IT because Q is equal to IT. Just substituting the value of Q through this equation, we obtain V into Q is replaced as I into T. That means current into time. From Ohm's law, what is the formula for the Ohm's law? Ohm's law is nothing but V is equal to IR. V is equal to IR. Hence, you have just substituting the value of V through this equation 4.19, we obtained V is equal to IR means IR into IT is nothing but I square RT. So, H is equal to I square RT. H is equal to I square RT. This is known as Joules Law of Heating. This is known as Joules Law of Heating. Joules Law of Heating states that the heat produced in any resistor is. This is very important point, children. Please note it down. Listen carefully. Joules Law of Heating states that the heat produced in any resistor is directly proportional to the square of the current passing through the resistor. So that means heat is directly proportional to the square of the current passing through the resistor. So when the current is square time increases means the heat energy also increases. Directly proportional means two terms are increases in a particular ratio. The first term is heat. Heat is directly proportional to the second term is square of the current passing through the resistor. So when the heat energy increases by the increasing of current, square of the current. So Joules law of heating states that the heat produced in any resistor is directly proportional to the square of the current passing through the resistor. Then second point is Joules law of heating is directly proportional to the resistance of the resistor. So the resistance value is increases means heat energy also increases. So heat produced in any resistor is directly proportional to the resistance of the resistor. So what is the working of resistor? Resistor is nothing but is a device which is resist the flow of charges. So resist the flow of charge means the charge should be rushed up in the circuit. So rush upping charge which produce the heat energy. So that is why when we increases the value of resistance, it will automatically increases the heat energy. So heat produced in any resistor is directly proportional to the resistance of the resistor. The next last point is heat produced in any resistor is directly proportional to the time for which the current is passing through the resistor. So time duration is increases means the heat energy also increases. So heat is directly proportional to time. So the long duration of time which produces the increasing heat energy. So this is very important point, last point. So heat produced in any resistor is directly proportional to the time for which the current passing through the resistor. So these important topics, these points are very important for the Joules law of heating. Please note it down. First point, second point, and third point, very important. Once again repeat, heat produced in any resistor is directly proportional to the square of the current passing through the resistor. Then second point is heat produced in any resistor is directly proportional to the resistance of the resistors. Then third point is heat produced in any resistor is directly proportional to the time for which the current is passing through the resistor. Next important topic is applications of heating effect. This is an important detailed question as well as the objective type question also. So applications of heating effect. So there are three applications, very important topic. Please note it down, children. Listen carefully. First point is electric heating device. Do you know the electric heating device? Electric iron, yes, electric iron, electric toaster, electric oven, electric heater, then induction stove, geyser, these apparatus for the heating device, electric heating device. The heating effect of electric current is used in many home appliances such as electric iron, electric toaster, electric oven, electric heater, geyser, etc. In these appliances, nichrome, please note it down, children. This is very, very important material. Nichrome, which is an alloy of nickel and chromium. So, which is an alloy of nickel and chromium. Please note it down, children. Heating element device is nickel and chromium. This is very, very important material for the heating device. Nickel and chromium is used as the heating element. Why? Because it has high resistivity. Second point is it has a high melting point. Then the last one is it is not easily oxidized. So three important point. So which one of this heating element, which metals behave like a heating element? Nickel and chromium. Please note it down, children. Nickel and chromium is used as a heating element. This is the important objective type question. Nickel and chromium is used as the heating element. Why? Because first point is it has high resistivity. Then second point is it has a high melting point. The third one is it is not easily oxidized. These 3 points is very, very important for a 2-mark question. Electric heating device. Properties of the electric heating device. This is a very, very important 2-mark question. Then second applications. Fuse wire. Do you know the fuse? The fuse wire is connected in series in an electric circuit. When a large current passes through the circuit, what happens? The fuse wire melts due to Joule's heating effect and hence the circuit gets disconnected. Therefore, the circuit and the electric appliances are saved from any damage. So, this is very, very important point. The circuit and the electric appliances are saved from any damage. So, what is the uses of fuse wire? The circuit and the electric appliances are saved from any damage. The fuse wire is made up of, this is very, very important point. Please note it down, children. The fuse wire is made up of a material whose melting point is relatively low. So, relatively low. So, whose melting point is relatively low. The fuse wire is made up of a material whose melting point is relatively low. Then third important point is filament in bulbs. Filament in bulbs. In electric bulbs, a small wire is used known as filament. The filament is made up of a material whose melting point is very high. So please note it down. This point is a very, very important objective type question. The filament is made up of a material whose melting point is very high. Then when current passes through this wire, what happens? Heat is produced in the filament. When the filament is heated, it glows and gives out light. It glows and gives out light. Tungsten. So this metal is called as a tungsten. So filament is made up of tungsten. Please note it down, children. Tungsten is the commonly used material to make the filament in bulb. So this is a very, very important objective type question. Tungsten is the commonly used material to make the filament in bulbs. So very, very important application for your 3-mark detailed question and as well as the 2-mark question. Also objective type question. The next topic. So this is also very important topic for your 2-mark question as well as objective question, objective type question. Electric power. What is mean by electric? What is mean by power? In general, power is defined as a rate of doing work or rate of spending energy. So once again repeat, what is meant by power? Power is nothing but rate of doing work or rate of spending energy. Similarly, the electric power is defined as the rate of consumption of electrical energy. Please note it down, children. Electric power is defined as the rate of consumption of electrical energy. It represents the rate at which the electrical energy is converted into some other form of energy. Suppose a current I flows through the conductor of resistance capital R for a time t. Then the potential difference across the two ends of the conductor is V. The work done W to move the charge across the ends of the conductor is given by the equation 4.19 as follows. W is equal to, already we know the formula for W. W is equal to VQ. Q is nothing but IT. So W is equal to V into IT. Here power is equal to work by time taken. So work is nothing but VIT divided by T. T cancel to each other. So power is equal to VI. Power is equal to VI. That means product of the potential difference and the current. So product of the electric current and the potential difference is nothing but power. So the electric power is product of the electric current and the potential difference, due to which the current passes in a circuit. Which the current passes in a circuit. So once again repeat, the definition of power is nothing but rate of doing work or rate of spending energy. What is the formula of power? Power is equal to potential difference into current. Next, very important topic for your objective type question, unit of electric power. Please listen carefully. Unit of electric power. SI unit of electric power is watt. SI unit of electric power is watt. When a current 1 ampere passes across the ends of the conductor, which is and potential difference of 1 volt, then the electric power is equal to volt into current. Here 1 volt into 1 ampere is nothing but 1 watt. 1 volt into 1 ampere is nothing but 1 watt. That means 1 watt is the power consumed when an electric device is operated at the potential difference of 1 volt and it carries a current of 1 ampere. So this is the statement of 1 watt. What is meant by 1 watt? 1 watt is the power consumed when an electric device is operated at a potential difference of 1 volt and it carries a current of 1 ampere. A larger unit of power which is more commonly used is kilowatt. Please note it down, children. Larger unit of power is kilowatt. Larger unit of power is kilowatt. Do you know this power? Unit of power? Horsepower, that means short form of horsepower is nothing but HP. That means the horsepower HP is a unit in the foot pound second. That means FPS system or English system. Sometimes used to express the electric power. It is equal to 746 watt. Please note it down, children. Very important objective type question. It is equal to 746 watt. 746 watt. Next, the last important topic is consumption of electrical energy. Consumption of electrical energy. Electricity is consumed both in houses and industries. Consumption of electricity is based on two factors. First factor is amount of electric power and second one is duration of usage. Electric energy consumed is taken as the product of electric power and time of usage. So this is a formula for the energy. Energy is nothing but electric power into time. Power into time is nothing but energy. Here energy consumed is taken as the product of electric power and time of usage. For example, if 100 watt of electric power is consumed for 2 hours, then the power consumed is 100 into 2 is equal to 200 watt hour. Once again repeat, if suppose 100 watt of electric power is consumed for 2 hours, then the power consumed is 100 into 2 is equal to 200 watt hour. Consumption of electrical energy is measured and expressed in watt hour, though its SI unit is watt second. In practice, a large unit of electrical energy is needed. This large unit is kilowatt hour. That means short form kWh. kWh means kilowatt hour. 1 kilowatt hour is otherwise known as 1 unit of electrical energy. Please note it down, children. This point is very, very important point for your objective type question. 1 kilowatt hour is otherwise known as 1 unit of electrical energy. So 1 kilowatt hour, how will you calculate this? Calculate this. 1 kilowatt hour. 1 kilowatt hour means that an electric power of 1000 watt has been utilized for an hour. That means how will you calculate the 1 kilowatt hour? 1 kilowatt hour is nothing but 1000 watt hour. 1 kilo means 1000. Watt hour. 1 hour means how much second and minutes in the 1 hours? 60 into 60. 60 minutes and 60 second. So 1000 into 1000 means 1 kilo. 1 hour it consists of 60 minutes and 60 seconds. So 1000 into 60 into 60. That means watt second is equal to 60 into 60, 3600, and into 1000 means 3.6 into 10 power 6 joule. So 1 kilowatt hour is equal to 3.6 into 10 power 6 joule. Please note it down, children. Very, very important value. What is the value of 1 kilowatt hour in energy means 3.6 into 10 power 6 joule. Joule is nothing but unit of energy. So once again repeat, 1 kilowatt hour is otherwise known as 1 unit of electrical energy. 1 kilowatt hour means that the electric power of 1000 watt has been utilized for an hour. So hence 1 kilowatt hour, 1000 watt hour, that means 1000 into 60 into 60 is nothing but watt second is equal to 3.6 into 10 power 6 joule. So consumption of electrical energy topic is very, very important for your objective type question as well as the problem question also. Thank you very much, student. Once again repeat the definition of Joules heating. What is meant by Joules law? Joules law states that Joules law of heating states that the heat produced in any resistor is directly proportional to the square of the current passing through the resistor. Then second point is heat produced in any resistor is directly proportional to the resistance of the resistor. Then third point is heat produced in any resistor is directly proportional to the time for which the current is passing through the resistors. So what is the importance of properties of the electric heating device? There are three important points. What are the material used in the electric heating device? Nickel and chromium is used as the heating element. What is the main properties of the electric heating device? It has high resistivity, it has a high melting point, it is not easily oxidized. The next definition is power. What is mean by power? Power is nothing but rate of doing work or rate of spending energy. What is the formula for the power? Power is equal to V into I. That means potential difference and current. So product of the current and the potential difference due to which the current passes in a circuit. The next unit of electric power is watt. In consumed commercial unit of electric power is 1 kilowatt hour. How will you calculate the 1 kilowatt hour? 1 kilowatt hour is equal to 1000 watt hour. That means 1000 into 60 into 60 is nothing but 3.6 into 10 power 6 joule. Thank you very much.